Greetings and welcome back to the lab. It's finally time to talk about the metronome project. It's related to the keyboard project. That's, I think, what I want to do first. But this is going to take a few episodes because I'm going to have to go through some of the groundwork on it before we start building. So if you want to skip this, you can. But when I start building, there may be a few things that I say that won't quite make sense. So I've tried to prepare ahead of time the best I can. Let's see how this goes. So now, this will be the cover plate for the metronome project, but I actually have a name for it. Redtronome. That's why I made it red. And it's got places to put labels for the individual oscillators, and this is the oscillator board. And so this has 1, 2, 3, 4, 5, 6, 7, 8 oscillators. We'll be building that soon enough. I set up 8 labels so that you can decide on 8 different frequencies for your particular metronome. So the idea, and I'll just give you a little bit of a sample here, if you combine the oscillators, you can get something kind of like this. Which, of course, you'd be able to hear a little bit better if I turned it up. Now, let me try and do that. Like I said, I try to be prepared. So that's one possibility. Now, I can do other things with it. Actually, right now I got that one muted. Let's see what happens if I unmute these two. The emphasis is a little bit different. So let's see now if I mute this and bring that in, it might be a little faster. Okay, so that gives you some sample of kind of what I'm planning here. This is all going to be square wave oscillators. I'm not trying to replicate a drum. This is simply a metronome, but it can give you a more complex beat. And in order to do that, you have to pick what frequencies you want to use. So I started thinking about what frequencies I might want to use, and I started mapping it out. And then we bring in the big board here. And so I've got it labeled across here, all of the oscillators, 1, 2, 3, 4, 5, 6, 7, 8. And so what I was thinking was, okay, I want to have 1/3 of a beat per second, or in other words, 1 beat every 3 seconds, 1/2, 1 beat every 2 seconds, 1 a beat every second, 2, 3, 4, 6, and then 8 beats per second. That's the 8 beats per second. Let's see if I can't solo this. Now that's kind of fast, but you can combine it with other things. So that ended up good. That ended up muting. Oh, by the way, I'm using Audacity, and I've got all 8 of these laid out. And there's one other thing I need to talk about, which is the green line here. But let's just try and do, let's see, let's unmute the 3. So this is the 3 and the 8 together. That should be interesting. All right, so that gives you some idea what's possible. Now, if you want, you can just literally have 1 beat per second. I'll even turn that up to make it a bit more obvious. There you go. So that's 1 beat per second. Now, if I want 2 beats per second, and I can go up to 4 beats a second. Kind of makes you want to tap your foot, doesn't it? So this is just sort of some demonstration of what I hope to be able to do with this in the end. I do need to mention, though, there might be some confusion, and I'm trying to avoid that here. If you want 1/3 of a beat per second or 1 beat every 3 seconds, that's actually 1/6 hertz. So 1 hertz is 1 cycle per second, and this is a representation of that square wave where, let me grab the blue here, your second shows up right here, right here, right here. So that's 3 seconds worth. And at 1 cycle per second, you actually are getting 2 ticks per second because it's going up and it's going down. And it's that transition that's making the speaker make that popping sound. So that is why I've written it down this way as 1/6, 1/4, 1/2, 1, 1.5, 2, 3, and 4. So really that is 4 cycles per second will actually give you 8 ticks. So that is what we're going to have to do in order to build this, is decide which of these you want. You could choose a different set, and then we're going to have to go through and actually figure out, calculate the resistors and capacitors involved in generating these particular frequencies. But we'll cover that, I think, in the next episode. Let me move this out of the way. The plan overall is to build this up, and this also, I should point out, in case you didn't watch the unboxing videos for this, there is an audio jack here and another audio jack here. Those will be for output, and then there are 2 power jacks side by side. So basically you can plug in your power and plug in a regular audio jack, an 1/8 inch jack, and run it to a speaker, some kind of powered speaker or something like that. What I had been doing prior to this was running a header up along the side and also up along this side, and using that with some pins stuck into the header to try and get it, and it just became a nightmare to try and tune these things because I had to hold a couple of wires while I was also tuning a very fine tuning potentiometer. But that was also a problem because my eyesight is not perfect, and trying to get the screwdriver lined up with that while holding this, and it was just a mess. So there's a revised design here. We'll go over that in the next episode as we start to build. Actually, maybe not the next episode, now that I think of it. And I think the next episode is going to be deciding on the resistors and capacitors for this particular set, and I will go through examples on how to determine what values you need in order to populate this board. And then in the episode after that, we'll start building. We'll start with just one oscillator and make sure it's working, which has been one of the problems I've had with this system. I keep redesigning the board because I run into problems like here. I had the idea for the metronome, and I wanted to do a 1 hertz signal on the very first oscillator, and I could not get it to tune. And it turned out that A, there was some wiring issues, but B, it was really just an issue of being able to fine-tune it properly, and there were a number of different problems. So anyway, that is where we are. This is the first episode. Stay tuned. We'll go through the design or the choice of the resistors and capacitors for those values. I'll probably breadboard it just to demonstrate it, and then we can start building the actual metronome or Redtronome. And the reason why there's 2 plates like this is because there are switches sticking up, and those will go through those holes, and that'll secure everything together as a sort of a sandwich. I've also designed a 3D box to kind of go around it, and there's a back plate here to kind of cover up all but the jacks that are there for power and audio. That is not in its final phase yet, but hopefully I'll be able to figure that one out, get it to its final phase, and then all of this will be available on my website for download, to download the designs, and then you won't be able to follow along exactly, well, yeah, you will. Actually, that's the whole point of these videos. If you want to build the same metronome, you can. If you want to make adjustments, I'm hoping to give you enough information that you can do that on your own, and then you'll be able to order up the top plate. You can make changes to the design if you want. The bottom plate, I wouldn't make any changes except in text or something like that, because this is very carefully laid out, and if you make too many changes, then it might not function. So, unless you really know what you're doing there. That, and yeah, basically all of these boards will be available and the 3D print once I get that finalized. So, thank you so much for watching. Stay tuned for the next episode.